In this lesson, we're going to look at polynomials, and we're going to start with a bunch of definitions. But as the lesson progresses, you'll see that a lot of the things that we talk about are things that we have done already when we looked at terms and simplifying algebraic expressions. So although, excuse me, some of the skills are going to be new, some of them are just so closely related to things that we've already done. So to start with our definition, a polynomial is a single term or the sum of two or more terms. And now when you hear the term sum, you're thinking adding only, but you could think of this subtract 12x squared as adding a negative 12x squared. So and this brings up a very useful way to think of each term. Think of each term as including the sign that's in front of it, okay? So if it's positive, we don't write the plus sign, but if it's a negative term, we do include the negative with it. Standard form for a polynomial, and this one is in standard form. Standard form always goes in descending powers of the variables. So I've got an x cubed, then the x squared, then the x, and then the one that has no x in it at all. So the degree of a term is the exponent of its variable. So if we're looking at just the terms, so I've got 15x cubed is one of the four terms on this example. Its degree is 3 because x to the power of 3 is the 3 is the power, the exponent on the variable. So negative 12x squared has degree of 2. 3x is degree of 1 because you can think of that as x to the power of 1. And a constant term, so long as it isn't the number 0, a non-zero constant term has a degree of 0 because you could think of that as negative 27 times x to the power of 0, which if you remember your exponent rules, x to the power of 0 is 1, so negative 27 times 1 keeps the value the same, so you can think of the degree as 0. Just the number 0 does not have a degree, okay? Okay. Now when we talk about the degree of a polynomial, the degree is whatever the highest degree of the terms are. So in the example from above, this first term has the highest degree. The degree is 3, so the degree of the whole polynomial is 3. It's a third degree polynomial. This next example, the highest exponent is a 5, so its degree is 5. So that's it for definitions. So let's look at, oh no, sorry, it's not. Almost. A monomial is a polynomial that has one term, and you'll hear especially binomials and trinomials a lot. Binomials have 2 terms, and a trinomial has 3 terms. Anything else we'll just call a polynomial with 4 or 5 or 6 terms. But monomial, binomial, and trinomial are 3 terms we'll use a bit. In order for something to be considered a polynomial, the exponents of the variables have to be whole numbers, okay? So the exponents have to be positive numbers, 0 or higher. Okay, so let's look at why these two examples here are not polynomials. Okay, so this in this first example, the 3x cubed is fine, but the 5x to the negative 2 is not because we have a negative exponent, so it's not a polynomial because of that negative exponent. And if we look at the second example, the first term is good, the second term is good, the last term is fine, but this term is not, because if you think about x in the denominator, that's really could be written as 4x to the negative 1. So that again gives us a negative exponent, so this one is not a polynomial either. So you have to have positive whole numbers as the exponents. Now we're finished with the definitions. So when we add and subtract polynomials, we're really doing what we've done before, which is combining like terms And then if we need to, we reorder into descending degree so that our final answer is in standard form. Okay, so adding is really straightforward. I've got a polynomial of 4 terms here of negative 5x cubed plus 12x squared plus 3x plus 12. And I'm adding this other polynomial, 6x squared minus 5x minus 16. When you're adding, we can just drop the parentheses and combine our like terms. So I've got negative 5x cubed. Are there any other terms that are like it? And to be like it, it has to have the same variable, remember, with the same exponent. There isn't, so this will be equal to negative 5x cubed. And then let's take a look at our x squareds. We have a positive 12x squared. We're adding 6x squared, so that will give us 18x squared. And then we have a plus 3x minus 5x, so that gives us minus 2x. And I have positive 12. I'm at a negative 16, so that gives us negative 4. And that's the solution. Okay, so we're just looking for like terms that we can combine when we're adding. In this second example where we're subtracting the polynomials, and I see I left out a parenthesis on the first example here. When we're subtracting polynomials, we need to think about how we subtract each of the terms in the second polynomial. And if you recall, when we were simplifying algebraic expressions and working on solving equations, we thought about what if we think about this as being minus 1 times each of those terms. So that means that when we remove the parentheses, we actually change the sign on each of the terms in the polynomial that we're subtracting. So we can drop the parentheses on the first one without changing anything, and then think about minus 1 or negative 1 times 6x cubed. So that becomes a minus 6x cubed. Negative 1 times 2x cubed will be negative 2x, squared. Negative 1 times negative 5x gives us a plus 5x. Negative 1 times negative 12 gives us a plus 12. Okay, so we've changed the sign on each of the 4 terms that that are being subtracted. So now we will collect our like terms. So I have a 7x cubed and I'm subtracting 6x cubed. So that will give me 1x cubed. A negative 12x squared minus 2x squared. So I have minus 14x squared. A positive 3x plus 5x, so plus 8x, and negative 5 plus 12 plus 7. So subtracting involves usually one more step than adding does because you need to carefully fix the signs in the polynomial that you're subtracting. Multiplying polynomials, and this is what the rest of this lesson is on, and the rules don't change, but what we're going to do is start looking for patterns to make multiplying polynomials a fast process, and in many cases eventually a one-step process, so that we can multiply polynomials quickly. In a separate lesson, we'll do dividing polynomials, which we give a special name called factoring, but that we won't look at the factoring today, but multiplying smoothly makes factoring more easily or more easy. So we're going to use our rules of exponents and we use the distributive property, and then our final step is always, if necessary, collecting or combining any like terms. So I've got negative 3x squared, a monomial, times 15x plus 2, a binomial. So remember the distributive property we tend to write with the arrows. We show what we're multiplying. So I've got negative 3x squared times 15x to get negative 45x cubed. I'm adding the exponents on the x's to get the correct exponent on the x in the solution. And then negative 3x squared times 2 will give us negative 6x squared. So that one's one step because these are not like terms. We can't combine them. So now I've got a binomial, 3x plus 2. I'm multiplying it by a trinomial. So let's take the 3x first and distribute it across the trinomial. So we're going to get 15 x cubed when we multiply it by the 5x squared. Then we'll get negative 18x squared and plus 9x. Okay, so we've taken the 3x, multiplied it by all three other terms. Now we're going to do the same for the 2. I'm going to multiply it by each of the three terms. So that's a positive 2 times positive 5x, so plus 10x squared minus 12x plus 6. And now we're going to simplify it because I see that there are a couple of x squared terms and a couple of x terms that we can combine. So I've got 15x cubed, a negative 18x squared, and a plus 10x squared. So that's a negative 8x squared. A plus 9x minus 12x is minus 3x plus 6. And that's our final solution now. And again, really looking for patterns is going to be helpful when we look at factoring. So when we're multiplying two binomials, notice that these are both binomials with an x term and a constant term. So when we multiply these, we end up getting sort of a pattern that you'll start seeing repeated once you do a couple hundred of these. So we're going to follow the same process we just did above. I've got 5x times 3x to get 15x squared. 5x times 7 is 35x. And now I'm going to take that think of that as a negative 2 times each of those terms. So negative 2 times 3x gives us a negative 6x. Negative 2 times positive 7 gives us minus 14. So the middle two terms are both x terms that we can combine. So we end up with 15x squared plus 29x minus 14. When we're factoring, what we're going to do is we're going to start with this answer and end up with what we have here as our question. So let's take a look at the pattern here that we see. If you think about the 15x squared, you can see where that came from. It came from multiplying the first two factors here, the 5x and the 3x. The negative 14 comes from the negative 2 times the 7. The middle term is harder to see where it came from, but it actually comes from multiplying the outside terms, the 5x and the 7, and combining that with the two inside terms, the negative 2 and the 3x. And that leads us to a thing, and this only works when you have two binomials that have a similar form. They have to have the same form as each other. So for instance, an x and a constant, or a t term and a constant. And there's this little thing called FOIL that helps you to use the distributive property quickly. And FOIL stands for first, and it's the firsts, so the first term of both binomials, then the outsides, so the two outside terms, then the insides, the two inside terms, and then the lasts, the two last terms. Okay, so let's apply FOIL to this next question D, and then if you're comfortable with FOIL, you don't have to draw the arrows, and often you can combine the two middle terms in your head once you've done a few of these. So we won't do that combining in this example yet, but let's just try FOIL. So multiplying our firsts, so that's 2x times x to get 2x squared. Our outsides, so 2x times negative 5 is negative 10x. Our insides, so that's 6 times x. And our lasts, so 6 times negative 5. Okay, our middle two terms we can combine now. 2x squared, negative 10x plus 6x will be minus 4x minus 30. If you are able to hold those two middle terms, the negative 10x and the 6x, in your head and add or subtract or combine them to get that middle term in one step, you could go right ahead and do that in one step. Here's another pattern that we can look for, and notice I'm multiplying two polynomials in the same form, so let's use FOIL on that. So if I do my firsts, I've got 16x squared. My outside will give me negative 12x. My insides gives me plus 12x, and my last gives me negative 9. look what happened in the middle here. I have a negative 12x plus a 12x, so that becomes 0. So we end up with 16x squared minus 9. Does this remind you of anything? Does it remind you of when we were multiplying conjugates in order to rationalize denominators? If so, it's because these two are conjugates. We've got 4x minus 3 and a 4x plus 3. So when we multiply conjugates together, we end up with middle terms that add up to 0, and our final result is just 2 terms. We can prove it by just using a and b as generic terms. If we use FOIL on these, we'll have a squared minus ab plus ab minus b squared, and so we end up with a squared minus b squared. This is one of those patterns that's really nice because if you recognize the pattern, you can go straight to the last line and very quickly say what the final result is. So let's try that with example G here. I have a pair of conjugates here, 3x plus 5 times 3x minus 5. So the result, remember, is a squared minus b squared. So my a is 3x and my b is 5. So 3x squared gives me 3x times 3x gives me 9x squared. And 5 times negative 5 gives me negative 25. And we can do that in one step. Let's take a look at H, which is also a conjugates, but the terms are a little bit different because I've got a t squared, but they're still conjugates of each other, so we can still think of this as a minus b times a plus b. So our result will be a squared minus b squared. So think about what 2t squared is. 2t squared means 2t squared squared, so times 2t squared. So that'll give me 4t to the power of 4. And then my b squared will be 49. So it's really cool when you start recognizing patterns when you're multiplying polynomials because it can provide you with a lot of shortcuts. Let's take a look at another pattern where I have a plus b and I'm squaring a binomial. Keep in mind that that means a plus b times a plus b. Okay, so I'm squaring those. So let's use, because they're binomials, let's use FOIL on that. So I'm going to get a times a, my firsts, so a squared. And then my outsides gives me a plus ab. When I do my insides, I see b before a, but I always put them in alphabetical order. So that'll be plus ab. And then my lasts plus b squared. So I've got a squared plus ab plus ab plus b squared. So if I have one ab and another ab and add them together, I end up with 2ab. So I've got a squared plus 2ab plus b squared. And that again is a pattern that's very useful to know. If you think about the 2x plus 6 squared, 2x plus 6 times 2x plus 6, we can use all the FOIL steps, but we can also use this pattern and think of what our 3 final terms are going to be. There's my a, there's my b. So my pattern says I'm going to have a squared. So 2x times 2x gives me 4x squared plus 2ab. So 2 times a, which is 2x, times b, which is 6. Plus b squared, which gives me 36. Now let's look at this middle term. I've got 2 times x times 6. So we put the numbers together. So 4 times 6 is 24. So I have 4x squared plus 24x plus 36. And again, if you can do this together in one step, just do it in one step. You're just multiplying the a term times the b term, so that gives me 12x, and then multiplying that by 2 to get the 24x. And in this third type of pattern to look for is subtracting, squaring a binomial where you're subtracting. So keep in mind this is a minus b times a minus b. So let's take a look at what happens and how that's different from a plus b squared. So let's use our FOIL technique again and use our firsts. So we get a squared. Our outsides will give us minus ab. Our insides gives us another minus ab. And our last gives us a negative b times a negative b, so plus b squared. Our two middle terms are like terms. I've got a negative 1ab minus 1ab, so I end up with a squared minus 2ab plus b squared. Notice how that's just slightly different from the a plus b squared, and that's where the middle term is subtracted. So now in example L, let's follow that pattern. And again, pressing pause and trying it on your own first is a great idea here. So I'm going to square my a, so that will give me 9t squared, and then minus 2ab. So a times b is 9 times 3t is 27t, times 2 is 54. So it'll be minus 54t plus b squared, so plus 81. So now we've done it in one step. If you need to see how that middle term came out, it's negative 2 times 3t times 9. So negative 6 times 9, 54. I'll just put that there. Okay. All right, so try the t minus 7 squared. T minus 7 squared, following that same pattern. There's my a, there's my b. So a squared will give me t squared minus 2ab. So ab is 7 times t, times 2 will be 14. So minus 14t plus 49. And that's it for today's lesson.